Good evening, everybody. I am Vibhu Swain from Power Tech Consultant. Today, we'll start our webinar number 32. Let me share my screen with you all. So, in webinar number 32, today we'll discuss about furnace, and this is basically chapter 4 of book 2, energy efficiency in thermal utilities. Now, we in this class we have earlier discussed the different type of furnace. Now, in this class, we'll discuss about the furnace efficiency, how the furnace behaves, why the furnace losses are low. So this is a important session, and you will all will be able to get benefit of this session, which will be discussing on furnace, and these are very important question as far as examinations is concerned. Now let us understand what is the amount of energy required to melt 1 ton of different types of metals at different molten temperature. That means for melting a metal you require a furnace. It might be mild steel, it might be aluminum or copper or gold or anything. So to melt a metal, what you require? We need to increase the temperature of the metal to its boiling temperature. That means once it attains its boiling temperature, what will happen? Or melting temperature, then what will happen? Once the metal goes to its melting temperature, it becomes converted to liquid form. So we have to increase the temperature of the metal, and we have to change the phase of the metal from solid form to liquid form. Therefore, thus there will be requirement of heat energy for specific heat requirement and as well as latent heat requirement. Now let us take an example of mild steel. What is the melting point of mild steel? 1650 degrees centigrade. Now, and this is 0.62. This is not the specific, it is 0.682. So, for 1 ton of mild steel, what will happen? 1000 kg into specific heat 682 into 1620 degrees centigrade by 3600 kWh. From where we got 1620? We have assumed a room temperature of 30 degree Celsius. That means the input temperature of the mild steel is 30 degree Celsius. Therefore, what happens here? In this case, delta T becomes 1650 minus 30, so it becomes 1620. So from this, we could get that we need almost, and this is in joule, and if I divide it by 3600, I'll get the unit in kWh. So I require 307 kWh of energy, electricity, to melt 1 ton of mild steel. Now, what is the latent heat of mild steel? It is 272 kilojoule per kg. Now, for 1 ton, it becomes 272 into 1000 kg divided by 3600 kWh. So it becomes 76 kWh. So latent heat required will be 76 kWh, and my specific heat for increasing the temperature, the heat requirement will be 307 kWh. So if I add together, then I got 376 kWh of energy is required for melting 1 ton of mild steel. Similarly, for aluminum, what the specific heat? 0.9, and latent heat of aluminum is 396.9. So if I add together, I'll get 180 kWh of energy is required to melt aluminum because its melting point is 710 degrees Celsius. Similarly, for copper, its melting temperature is 1130 degrees Celsius, and amount of energy required is 117 kWh. The specific heat is 0.386, and the latent heat is 212 kilojoule per kg. Similarly, for gold, it is 56 kWh. That means whose melting temperature is high here? No doubt, mild steel melting temperature is high. Therefore, and the specificity is also good. Therefore, we require very high energy to melt mild steel. That means 376 kWh, whereas aluminum it is little bit lower. Copper it is 117 kWh, and for gold it is the lowest. So in this, you have to remember might be this kWh and the melting temperature. Now, what is furnace efficiency? Furnace efficiency is basically the theoretical heat required for melting. That means how much of heat is required for melting. So these are all are theoretical heat required to melt 1 ton of these materials. But actually, we require more electricity. So actual electricity consumed for melting will be higher. Why? Because of the losses in the furnace. There are various types of losses which we'll discuss today, due to which furnace efficiency is low. So furnace efficiency is theoretical heat required for melting divided by actual energy or actual electricity consumed in kWh. Now, what is the heat required for melting? As I discussed, weight of metal, then specific heat of metal, delta T, that means the final temperature minus initial temperature, the melting point minus the initial room temperature, and H is the enthalpy or the or the latent heat. So H is the latent heat. And why we are dividing by 3600? It is because 3600 kilojoule is 1 kWh. Now, similarly, heat required for melting slag. Slag, you have to remember, you have to multiply 1.65 into weight of slag in kg divided by 3.6. So 3.6 megajoule is equal to 1 kWh. So this is in kWh. So you have to remember that for slag we have to multiply 1.65 into weight of slag in kg. So these are the formula, and this is the Cp is the specific heat of the metal, final temperature of the metal, T1 is the initial temperature or charge temperature of the metal. So what is the theoretical heat required? H2 becomes H1 plus H2. An actual electricity consumed can be measured in a meter, and it is HA. Let us see. Now, let us do this example. Now, in this case, we have to calculate the furnace efficiency. What is the specific heat? 0.682. It is a MS scrap. Scrap is specific heat is 0.682. Latent heat, as we discussed, it is 272 kilojoule per kg. Melting temperature is 1650 degrees Celsius. Charge temperature is 30 degree. Quantity of metal is, let us say, 1 ton 1000 kg. Quantity of slag generated. Slag is basically when you heat in a furnace, you got some slag, so it becomes 25 kg. And electricity consumed, this is the actual electricity consumed, that is 625 kilowatt hour or 625 unit. So H1 becomes 1000 specific heat delta T plus latent heat 272. I got 382.45 kWh. H2 I have to multiply 1.65 into 25 by 3.6, it becomes 1145 kWh. So what is the total theoretical heat required for melting? H T becomes 394 kWh. But if you see, if theoretical heat required is 394 kWh, then why you require so much of energy, 625 kilowatt of energy for melting? Because there is your losses. So furnace efficiency becomes theoretical heat, that is 394 divided by actual electricity consumed, that is 625. It becomes 63%. Now, as I discussed, because the theoretical energy is in the range of 385 to 400 kWh per ton, but whereas the specific electricity consumption becomes 550 to 950 kWh per ton. So there are losses of electricity or power loss is happening, or these are known as furnace losses. So what are the normal percentage? These are ballpark figure. Normal percentage of power loss is become 2 to 4%. In capacitor bank also, since some resistive component also is there, and why you require capacitor? Because furnace is an inductive load, So to improve power factor, you have to apply the capacitor bank in the furnace, and since it contains some resistance or resistive element, so there will be some resistive loss will be happening, that is 1 to 3%. So power loss in crucibles, these are important. As I told you, in furnace, what is there? In induction furnace, there is a crucible in which water jackets is there, water cooled cables are there, and bus bar changeover switches are also there. These water cooled cables takes the heat from the crucibles so that the crucible does not melt. So these are basically cooling requirement. You employ some water cooled cables or pipes, due to which there is a, and there is some water cooled bus bar also is there, because the current rating is very high, and there is a changeover switch. Sometimes you charge in delta, sometimes you charge in star. So based on induction heating, you have to change the switch. So because of which there is a loss of around 18 to 25%, which is a huge loss. And of course, furnace, any temperature or any high heated temperature body radiates heat, so there is a radiation loss of 7 to 9%. So these are the major loss in furnace. Now, what are the factors affect furnace efficiency? Let's just understand that. Can be poor maintenance, as I told you. Now, if your maintenance is not proper, what will happen? The production will stop. And once the production stops or there is a breakdown, so what will happen? You need heating time. You have to heat up the furnace to attain that temperature. Again, you have to cool down. So whatever the once any breakdown happens, so there is a heat loss occurs, and which increase the cost of productions. Now, let us say voltage, there is a low voltage problem in particular area. Now, if there is a low voltage problem, what will happen? P is equal to V square by R. So, if V reduces, then automatically power requirement will be low. Now, because the power requirement is not adequate or is low, or power supplied is low, what will happen? The furnace will take a lot of time for melting. Now, because of this holding time or because of this long delay of melting, there will be energy loss. So there will be production loss also, and it will increase the production cost. Now, sometimes what will happen, if your lining is not correct? Lining is basically, these are refractory materials. We need to, because furnace is basically a iron crucible. So we need to put some refractories so that 1650 degrees Celsius, the molten metal does not come out of the holder or the crucibles. So there are two types of refractories. One is basic refractories, another is acidic lining. Now, basic lining is basically the better conductor of heat as compared to acidic lining. So what we have to put in furnace? We have to put basic or acidic? No, we have to put acidic lining in furnace, because these are bad conductor of heat. Now, if your lining selection is not proper, what will happen? One, it will be breakdown will occur, and this will be increase the furnace downtime. Also, heat loss will be happen, because basic lining is better conductor of heat, and these are result in inefficient operation. Similarly, sometimes if you have seen any induction furnace, if there is no proper coordination, there is a crane, there is a crane operator, if doesn't give material in time, and there is a field operator or melting staff and contractor, there are also some losses occurs. Absence of material handling equipment, you require a lot of good material handling equipment like cranes, hoist, to pour material into the furnace, to lift the material, to mold the material, to mold the furnace, to tilt the furnace. So if they are not available also, you will incur loss. Then poor molding efficiency. If molding or tilting is not working, then automatically furnace will be kept on hold. You cannot get the material out of the furnace, so there will be losses. Poor quality scrap is another area, and it also reduces the lining life and takes more time to melt. Absence of thermal insulation between lining and coil. So these are the major factors which affect furnace efficiency. Now, if you contribute or concerned, or if you take care of all these factors, what will happen? Your downtime will be low, your uptime will be high, your breakdown will not be there. So furnace will work very fine, and there will be no major losses, and furnace will be efficient. Now, how we perform or how you evaluate the performance of any furnace? Basically, it can be two methods. One is direct method or it's indirect method. It is same as like boiler, oven, heater, kiln. So anywhere, any thermal energy, normally the heat loss are typically same. So we need to understand the basic concept so that it will be easier for us to know or evaluate the performance of any furnace. Now this is basically heat delivered, it is the ratio of heat delivered to the material divided by heat supplied to the heating equipment. Now let us see, this is the furnace. Now you need to get high temperature, you need to apply heat so that the molten ore melts, or you need to increase the temperature of the product. So heat delivered to the material, so heat, useful output or the heat to load divided by actual heat applied is the furnace efficiency. Now, why furnace efficiency is low? Because what is happen in case of boiler, you don't require very high temperature inside the boiler. But in case of furnace, you require very high temperature, maybe 1650 degrees Celsius for iron melting. Now, once your temperature is high, what will happen? Automatically, there will be high dry flue gas loss will happen because of the high temperature of the flue gas. So high stack temperature, excess air level, these are one of the major reason of low efficiency for furnace. Low capacity utilization, harsh loading, radiation losses due to opening. If you keep on opening, closing the furnace, then there will be some radiation losses. Surface heat loss also will be there. And sometimes if you are doing batch operation, that means putting some material, heating, again cooling the furnace, again after sometimes you are heating. So in case there is a batch operation, so there will be furnace uptime and downtime, due to which there will be heating, cooling, soaking cycles. And during particularly cooling cycle, what will happen? The furnace will lose lot of energy. Now, various type of furnace losses. So as I discussed, these are the furnace losses. One is opening loss and wall loss, dry flue gas loss, or the flue gas which takes it. And if there is some opening loss will be happening, and some amount of energy stored inside the furnace. Once the furnace goes for breakdown or shutdown, this stored energy is released to the atmosphere. So these are the cooling, because water jacket is there or water cables are there. Therefore, there will be some cooling water loss will be there happening. And if you are putting some material into conveyors, or maybe through a cable or a buggy type, then there will be some conveyor loss will happen. So these are the major loss of furnace. Now, what is stored heat loss? Stored heat loss is basically heat stored in the furnace structure. That means the metal structure, the insulation of furnace has to be heated fast. Unless it is not heated, it cannot be do its working. So now once that you require some heat energy to heat the metal structure inside furnace and the insulation of furnace. Now this heat energy is stored as long as the furnace operates. Now if furnace goes for a breakdown or shutdown, then what will happen? This released or the holded energy or the stored energy get released to the atmosphere during the cooling process. So there is a loss of stored heat loss during cooling time or during furnace downtime. So these are known as stored heat loss. Now, what is wall loss? Now, let us say this is the furnace wall. What will happen? And heat energy is inside the furnace or the crucibles. And there are some insulation is also there. Now, because this is a very high temperature, heat is being applied to the insulation, what will happen? There will be some conduction, heat will, because of conduction, the heat will transfer and will come or reach this point or to the surface. So from the inner surface, the heat will come to the outer surface. So due to which now because it is a hot temperature, what will happen? There will be some radiation loss will happen. Now if some air velocity is there, then this air will get heated up and also get cooled, so due to which there will be some convection losses. Now once due to radiation and convection this temperature goes out, what will happen? Then it or the heat is got out, then the again more heat will be taken in. So this is a continuous process, so there will be some wall losses or the losses to the wall. Then material handling losses. Now let us say you need to heat a material, but you need to convey the product into the furnace. So there will be some hangers or some particularly hot car. Sometimes in the bogie type car, you put a product and take it into the furnace. Once it heated up or melted, you take out. So these car structures or the hangers or the material handling which is going inside the furnace also, when they come out, what will happen? They are also heated up. So that heat energy is released to the atmosphere. So there are some material handling losses occurs in the furnace. Cooling media loss, as I told you, because we need to protect the furnace. So there has to be some water, air cooling, protect rolls, wearing door, all things needs to be cooled properly. Now, this cool energy, what will happen? This water medium takes the output heat or the outside heat and again get cooled. Due to which some energy loss also happen. Now, radiation opening losses. Now, let us say this is a furnace where the metal has to go out. If you keep it open, this is a very high temperature zone is there inside the furnace. Now, there is a radiation loss which is almost fourth power of the surface absolute temperature. Remember this: if 30 degrees centigrade is there, then absolute temperature will be 30 plus 273 Kelvin. So the radiation loss or radiation heat transfer is basically fourth power of the surface absolute temperature. If the surface temperature is very high, then the heat transfer will be very rapid and faster. Now, since it is 1650 degrees Celsius, so there will be huge radiation losses which occurs due to opening of the furnace. So, you need to close the furnace as quickly as possible to stop the radiation losses. Waste gas losses, as I told you, the some heat is there in the gas because CO2 is formed, water vapor is formed. Now, these gases takes out some of the heat and goes to the chimney, and due to which there is a waste gas losses also happen. Now, air infiltration. Now, what is happening? We need to, there is ID fan which take out the furnace waste gas or the dry flue gas. Now, there is a normally negative pressures is there in the furnace. So what will happen from the outside through the leakage of the furnace or through the furnace different opening, the air leaks because it is in vacuum condition or negative pressure condition because IT fan is operating. So because the air is infiltrating, it is a low temperature air, it takes the heat of the furnace and goes out. So there is a, because of the air filtration also some losses occurs in the furnace. Now, how to evaluate the furnace efficiency? As I told you, one is direct method. So let us do a problem on direct method. So thermal efficiency of the furnace is basically amount of heat added to the stock divided by heat in the fuel consumed. So what is the heat added to the stock divided by heat in the fuel consumed for heating the stock? Now, what is the heat imparted or Q to the stock? It is normal. M is the mass of the product. Cp is the specific heat of the stock. T1 minus T2 is the final temperature minus initial temperature. So initial temperature means at which the product entered to the furnace. So MCP T1 minus T2 is the quantity of heat imparted to the stock. Now, what is the heat energy in the fuel? It is quantity of fuel Q into GCV, gross calorific value of the fuel. Now, with this, as in boiler, we can also find out the thermal efficiency of furnace. Now let us do this example. Now, what is the operating parameter of re-rolling mill furnace? When you go to for audit exercise, you need to calculate furnace efficiency. So it is also easier for you how this furnace efficiency can be calculated. Now weight of the input material is 10 ton per hour. So that means per hour 10 ton of material is going. So it is a continuous process. Or no, re-rolling means it is a material is going in and going out. So furnace oil consumption is 600 liter per hour. What is the specific gravity of oil? It is 0.92. That means density is will be 0.92 liter per kg, let us say, or kg per liter, 0.92 kg per liter. Final temperature, product temperature is 1200 degrees centigrade. What is initial inlet temperature? 40 degrees centigrade. What is the outlet flue gas temperature? 650 degrees centigrade. Now, what is the specific of these materials? Specific heat you require, it is 0.12 kilocalories per kg per degree Celsius. GCB of oil is 10,000 kilocalories per kg. Percentage yield is 92%. Percentage yield means the amount of furnace which goes or the metal goes, same metal does not come out. There will be some slag loss or some losses in the material. So percentage of yield is 92%. So we have to calculate the furnace efficiency by direct method. So what is the heat input? Fuel consumed, that is 600 liter per hour. Specific heat 0.92 is unitless. Why 10,000? Because the GCB is 10,000 kilocalorie per kg. So 55240 kilocalorie per hour heat is required inside the furnace. Now what is the heat output? Delta T 1200 minus 40. This is delta T. What is the 10 ton? So 10 into 1000 is the 10,000 kg. Specific heat is 0.12. So this much of heat output goes out along the product. So this is the heat being taken by the product itself. What is input heat? It is 55200 kilocalories per hour. So what is the furnace efficiency? It will be this divided by this, it becomes 25.2%. Now, what is the weight of the finished product? Weight of the input material is 10 ton per hour. What is the yield? 92%. So what is the weight of the finished product? 9.2 ton per hour. Furnace oil consumption is 600 liter per hour. 600 liter per hour. So what is the specific fuel consumption? Is 600 by 9.2. It becomes 65 liter per ton. So there are two major parameters which are required to be ascertained while carrying out furnace evaluation. So one is furnace efficiency, another one is specific fuel consumption. This furnace efficiency should be very high and specific fuel consumption should be low. So with this, I conclude the today's sessions, and we have discussed about furnace efficiency, what are the major point of furnace efficiency, why furnace losses happens, and how we can calculate the furnace efficiency and specific fuel consumption of a furnace through direct method. With this, I conclude. Thank you and good night.